Hey guys, sorry I couldn't be with you today. I just been feeling a little bit under the weather and I need to get better, so I don't want to get any of you dudes sick, so I just stay home today and I'm gonna get better and I'll be back tomorrow, okay? So, one, I just want to say make sure you're good today for the sub. Um, Make sure you're taking notes today, alright? Remember, we're on crunch time. We want to get our stuff done before the SOL, which is next week. Okay, so I want to make sure that you are taking notes and following along. So, with that being said, we're skipping warm-up today. Hallelujah, right? I know you guys are happy about that. And we're going to skip warm-up today, and we're just going to go ahead and get right to it, okay? So, if one of you guys could go ahead and grab the big thick stack of packets and pass one to each of your classmates. I'm going to pause the video right now, and when you are done with that, you can go ahead and start the video back up again. Alright, ready? Set. Here we go. Alright, so let's talk about some statistics, okay? So, even before we do this, actually, let's go ahead and just... Alright, we're going to talk about, just as a quick review, alright, here's some things you should have talked about in classes before. Okay, so these are measures of central tendency, and I know because I've read your science SOLs that you should have studied median, mean, and mode at some point this year, or at least used them, okay? And if you haven't, this is not the time to start freaking out about that, okay? Just kind of move on. We're going to move on and we're going to focus on it now, okay? So, median, this is like the middle, okay? And that's the middleest data point we have, right? So if I have 1, 2, 3, 4, and 5, I count in from the outside. So 1 and 5, 2 and 4, and so 3 is my middle data point, okay? Now, even if my data points are like 1, 2, 12, 15, and 71, okay? If I want to find my middle data point here, I'd say 1 and 71, and then 2 and 15. So my middle point is 12, all right? That is not the average. It's not the balance point of the data set, but it is the middle data point, okay? So we'll talk more about the median when we get to box and whiskers. That'll probably be tomorrow, okay? So for now, that's what the median is, okay? But that's not our main concern today. Our main concern today is the mean, which is the average, okay? Or it's that balance point for the data set. Okay, so what that means is the point that's equal, it's an equal distance from the lowest data point and the biggest data point. So that kind of, if you were to put the data set on a number line and you were to put your finger at the mean and lift up that number line, the whole thing would balance around your finger. Okay, so the mean is the average, and we'll talk about calculating that in just 1 second. All right, mode is the one that happens most often, okay? So most often sounds like mode. That's how we remember that. So that would be in this data set 1, 2, 5, 5, 6, and 8. 5 would be the mode because there are 2 5s, and that's the data value that happens most often, okay? So let's talk more about mean. All right, so average. Here's a data set, and these are some math scores that I made up, so they don't belong to anyone. Okay, so no FERPA violations here. Math scores. Okay, I want to start off by finding the mean. Okay, so first, just to get some visuals down, I'm gonna go ahead and put these on my number line that I have nicely written out here. Okay, so my first one is 97, so that's gonna be 91, 92, 93, 94, 95, 96, 97. Okay, and just so you know, these, you don't have this on your piece of paper. This is just review right now, okay? 91, I have an 83, I have an 80, I have an 85, 81, 82, 83, 84, 85, and let's see, we use 85, 80, 83, 91, 97, and now we need a 72. So there's my 72. Okay, so I have my data points out here, and now I'm going to go ahead and find my average. So I'm just going to jump right to it. Finding an average, basically what you do is you add up all the data points. So 85 plus 80 plus 83 plus 91 plus 97 plus 72. and then we're dividing all of that by the number of data points in the set. So in this case, that's 1, 2, 3, 4, 5, 6. To see, you know, what is the balance point of the data set? You know, where is it centered around? What's it centered around, okay? So when we add all this up, let's get out our handy dandy calculator. All right. And by the way, you know what? I'm just going to pause the video again. Pause the video right now, and if you do not have a calculator, you need to go get one right this second, okay? And also, do not make anybody else clean up after you today, okay? You better put those calculators back where they came from. All right? Pause the video now and go get yourself a calculator. All right. Welcome back. Now, hopefully, we all have a calculator out. Okay? We are going to go ahead and plug in our data that we have here on this list, and we are going to find an average. Okay? So, 85 plus, sorry, you can't see that. All right, 85 plus 80 plus 83 plus 91 plus 97 plus 72. Okay, so we add all those up, 508, and then we divide that by 6, the number of things that we have in our data set. All right, which we need to convert now into decimal. So I think if you push enter again, no, that's not what I wanted to do. I want to convert this thing. I want to convert 254 divided by 3 into a decimal, so I push number, right? So menu, number, convert to decimal. And I know you guys know another way to do that, and I'm not 100% sure how to do it, so I'm going to leave that one to you. Okay, but I get this number, 84.666666 repeating, which rounds to 84.6667, which we can just kind of say is 84.67 for our purposes. Okay, and that's the mean of our data set. All right, so there's two different ways you need to get used to seeing mean. It can either be written as an X with this bar over top of it, which you can kind of think of as the balance point of the data set. If you look at this bar, this is our number line. Okay, so X bar, or this little funky U looking thing, which is like a U with two tails on it. Maybe if you like pulled a cursive U out of the middle of a word, then you would get this letter, okay? And this is the word mu, which is a Greek letter. And this is the word that your SOL formula sheet has. So if you go ahead and pull out your SOL formula sheet, it should look like this. All right? And what we're dealing with today is this stuff, statistics formulas, okay? So here we see that funky little mu symbol. And that represents the mean of the data set. So if you ever forget what it means, then it's right here on your formula sheet, okay? But the important one to remember is that this is what it looks like in your calculator, and we'll see that in a second, okay? But anyway, so we found the mean, and that mean was 84.67. Okay, so let's go ahead and put that in a different color on our number line. So 84.67, so that's almost 85. All right, so here's our mean. All right, now if we look at all this data, that's roughly about the middle of the data, right? So now what if I said, all right, well, I want to know how consistent am I as a math student? Okay, let's say these are my scores, and I want to say how consistent am I? How far away from the average, my average, is each of my data points, right? Well, what that is called is a measure of dispersion. Oopsie, I still have the line tool. Dispersion, okay? So dispersion is like if I disperse something, right, I scatter it. So we're looking at how scattered is my data. How, if I were to go take any test and just kind of go into it, how accurately could I predict my test score based on how scattered I usually am? If I'm all over the place, I can't, it doesn't matter what the mean is, really. I'm going to have really big dispersion. But if I'm usually scoring around an 85, then I know, and all my data points are all really close to 85, then I know that I'm going to have low dispersion, okay? So let's try to figure out, let's find an average of this. Average dispersion, okay? So a word we're going to use a lot is deviation. Oh, just killed a bug on my screen. That's gross. Okay, it's deviation. Okay, and that means the difference from the mean. Okay, the distance or the difference. So the distance from the mean, which is also the difference. And difference is one of our words that we use to say subtract. Okay, so let's go ahead and find, I'm going to make a little chart here. Okay, so x is each element of the data set. And if we look at the formula sheet, we also see this xi that you need to understand. Okay, the xi means the ith data point. Okay, and I'll show you what that means right here. Okay, so see, we have I. All right, so we can number the elements of our data set. In our data set, we have 6 things. Okay, so 1, 2, 3, 4, 5, 6. Now, if we put our things in there, 85, 80, 83, 91, 97, 72. Okay, so if I said x2, what I would be saying is, look at this one that says 80. All right, so we want to find our standard distance from the mean. So what that is we take our data element and we subtract the mean from it. Okay, or this could look like x minus x bar. Okay, so 85 minus 84.66666 repeating. I don't like doing those fractions, so let's do 85 minus 84.6. Alright, so that's about 1/3 deviation. Alright, 80 minus that is going to be negative 4.6 repeating. Alright, 83 minus 84.66666 is going to be negative 1.66 repeating. Alright, let me just double check that. Don't want to do anything wrong here. Yeah, negative 1.6 repeating. Okay, 91 minus, so all I'm doing here is I'm just subtracting the mean from each data point. Okay, so 91 minus 84.6 gives me 6.3 repeating. Alright, this is 0.3 repeating. Alright, 97 gives me 12.3 repeating, and then 72 is negative 12.66 repeating. Okay, so what you'll notice is that all the things that were less than the mean, all the things that were under the mean, those are going to be, they're going to have negative deviations, okay? And what that means is those data points are less than the mean. So obviously the data point minus the mean's a bigger number, it's going to give you a negative distance, okay? So that means it's below, it's closer to 0 than the data points on the other side. Okay, so it's between 0 and the mean, and then anything with a positive sign is between the mean and positive infinity. Okay, so we see this has a negative sign, this has a negative sign, and that one has a negative sign. Whereas, I'll change colors here. This has a positive sign, that has a positive sign, that has a positive sign. These are above the mean, these are below the mean. Okay? Alright, so now we want to find the average deviation here. Okay? So, in order to find the average of something, we add everything up and we divide by the number of data elements, okay? So, what we're going to do is we're going to add up, hello, I want to see that. We're going to add up 0.3 repeating plus negative 4.6 repeating plus negative 1.6 repeating plus 6.3 repeating plus 12.3 repeating plus negative 12.6 repeating. Okay, so I'm going to pause and add that all up for you. Okay, so I added up all the things that were in our numerator, which are all the deviations, so all of the x minus the means, okay? And I added those all up, and it gave me this negative 1e negative 12. So what that means is basically 0, okay? What that means is because we have infinitely repeating decimals, but we can't type infinitely repeating decimals into the calculator without converting them to fractions first, and I was too lazy to do that, we have a tiny bit of error, but it's like e to the negative 12th. So it's like a billionth, except for smaller. It's like 100 billionth, okay? So it's not that, it's basically 0, okay? Alright, so to find the average, we also have to divide by the number of data elements, and in this case that's 6. So we found that the sum of the top is 0, and then we're dividing that by 6, so 0 divided by 6 equals 0, which is completely uninformative. What that's telling us is every single one of our data points, the average distance that our data points are from the mean is 0, and that doesn't make any sense because clearly we have a spread of data here. We have a bigger average distance than 0. I can guarantee that we are all not spot on the mean, okay? None of these data points are equal to 84.67, so not even one of these has an average deviation of 0, okay? So that doesn't make any sense. So what we've come up with in the statistics world is we've come up with these additional measures of deviation or dispersion, how spread out the data is, and the whole purpose of that is how do we make this not 0? Well, what's causing it to be 0 in the first place? And I think that's a really important thing to say. Look at, okay? So if we look at this point 3, this is right here. That's at 85 between this point and the mean, okay? And then if we look at this negative 4.66, that's from 80, okay? So let's draw that. All right, there's that distance there. Okay, and I'm going to draw it in red if it's negative and blue if it's positive, okay? So red distance. Okay, what other red distances we have? 83, that's a red distance, okay? So there's a red distance. And then 72, there's a nice big red distance, okay? All right. So we have all these red distances. Oopsie. And I erased part of something and I don't care that much. Okay, so we have all these red distances, and now let's put some blue distances on here. Okay? These are our positive distances. Okay? Positive distance, positive distance, positive distance. Well, what we're bumping into is that these positive distances end up canceling out the negative distances, right? Because if the mean is the balance point of our data set, then all of the average distance that everything should be away, or not the average distance per se, but the distance that each data point within the set should be, that mean should be the middle point. So all the negative distances should cancel out all the positive distances, and that's exactly what we see happening. The issue is I still want to be able to predict my test score, okay? So because I want to be able to predict my test score, I want to be able to describe this dispersion. And what's really busting me up, what's causing me my issues, is these negative distances here, okay? The fact that those negative distances are canceling out positive distances. So the way we've come up with doing this is the mean absolute deviation, okay? Mean absolute deviation, the variance, and the standard deviation. Okay, so pause the video right now, and I want you to find the page that looks like this. It says mean absolute deviation at the top, and we are about to do some notes, so get ready to go. Alright, here we go. So, measures of variability, or spread, or dispersion, okay? They give us information about how spread out the data elements are, okay? So the higher the value of the measure of that variability, the more spread out the data is from the mean. So if we look at each of these data sets below, okay? So here, here, and here, we want to know, all of them have the same mean, right? But we want to know how spread out is that data, okay? Now, clearly this one shows the least variability because almost all of our data points are equal to the mean, okay? And this one shows a pretty good spread, and this one shows a pretty good spread. But the question is, which one shows more spread, right? Is it when it's all weighted at the two ends of the data set, or when it's spread out evenly across the data set, right? We don't know. We're going to figure that out, okay? So, there's the three measures I was talking about. Keep going. And the visual deviation, that's what I showed you just now about how it all cancels out, okay? So we can't just average those distances, we have to find a way to get rid of the negatives. And one of the best ways to do that is our handy dandy absolute value. Okay? So in mathematics, the mean of the data set is the average. Okay? Alright, we talked about that just a second ago. And another math term that we can think of that has the word absolute in it, well, that's absolute value, like I just said. Okay, and what does that term mean? Okay, that means whatever's inside of our absolute value signs, you want to take the positive. Okay, so let's take the positive because we want, take the positive, because we want the distance from 0, okay? And we're only talking about positive distance from 0. So -2 is actually only 2 away from 0 is what that's saying, okay? So then the term deviation means the distance from the mean. So these are some terms we've already defined gone back over, okay? So the mean absolute deviation is the average, okay? Mean means average. Absolute means positive deviation, okay? Or the average absolute value of the deviation of each term. Data element. All right, and an element's another tricky word that we use to just talk about any one piece of our data set, okay? So in our data set, 85 would be an element of the set, okay? So to calculate the mean absolute deviation, I know you're dying to know, and it makes a lot of sense. Are you ready for it? Okay, first you find the mean of the data set, okay? And then you subtract the mean from each value, okay? When we subtract the mean from each value, we are finding the deviation, okay? Then we have to take the absolute value, go figure, of each deviation from the mean, okay? From there, we're finding the mean absolute deviation, so we are finding the mean of the absolute values, we are finding the sum. The whole process for number 4 is finding the mean of those, okay? We are finding the sum of the absolute values and dividing by the total number of items, okay? Number of items is always designated by n. That's on your formula sheet right there. N represents the number of elements in the data set, okay? All right, so n, number of items. Ooh, you gotta pick it up. Pick up the pace. All right, so we're gonna go through this one really fast, okay? So what I'm gonna do is everybody get out your calculator and I want you to make a new document, okay? All right, make a new document. So home button and new document. We are going to not save the old one. We are going to add lists and spreadsheet. So we're just going to start by naming each of our lists, okay? All right, X and Y. And we are going to input our data set, just kind of like we're starting off making a curve of best fit, okay? And we only have one variable, so we only need one variable, sorry. Okay, so we have 83, we have 80, we have 80, we have 80, we have 74. All right. Now, you ready for the magic? Here it comes. Push menu. And if you need to pause the video right now before I keep going, please pause it, finish getting your data in the calculator, and then we'll keep going, okay? All right. Push menu, and we go to statistics, and then we do stat calculations, and we do one variable statistics, okay? And we just keep pushing OK until a whole bunch of stuff shows up on the screen. Voila! The calculator just found the mean for us. It's awesome. There's that X bar I was talking about, okay? And that's the mean. So 79.4 is the mean. So I can go over here and say 79.4. Sweet O. All right. Now, what it's asking us here is to find the distance from the mean, okay? So that means that each data element, you subtract the mean from it, okay? So let's do that real fast. Okay, so I started doing this, and see we have our absolute value bars here. So anytime we get a negative number, we're just going to take the positive, or when we get a negative number for that deviation, we're just going to take the positive form of that deviation, okay? So this is going to be 0.6, and now 74 minus 79.4. All right, we got negative 5.4, but since we're taking the absolute value of that, that's going to be a positive 5.4. All right, so now down here it's asking us to find the average of that, right? So in order to find the average, we got to add all these things up and then divide by the number of things in our set. Okay, so we have 3.6 plus 0.6 plus, not negative, 0.6 plus 0.6 plus 5.4. Okay, and we have 1, 2, 3, 4, 5 things in our set. So then we're going to divide that by 5. It gives us 2.16. So what that's saying is the average of the absolute value of our deviations is 2.16. So if I want to see if my test average is an 85, that means that if I take a test, I can pretty much expect to score between 85 minus 2.16, right? That means I'm usually about 2.16 away. I'm within a window of 2.16 on either side of the mean. So I'm either going to be 79.4 minus 2.16. Okay, which is 77.24. Alright, so I'll be between 77.24 and, I did the wrong thing, sorry. I'm at 85 minus 2.16. That's the mean, okay? So 82.84. I'm between 82.84 and, 87.16, okay? So that gives me a pretty good estimate. If I just kind of go take a test, that's kind of where I'll be, okay? Well, this is, if we pick any random player from the Miami Heat, they're probably going to be within this, okay? All right, so I'm going to pause real fast and fill in the rest of these charts. Okay, I'll post these notes online so that filling in the charts, if you miss some of them, you can get those. But the key is to make sure anything I emphasize, write that down, okay? So hold on. All right, I actually want to show you something really fast. If we're looking at what's happening here, if I go in and I decide I need to change one of my data values a little bit because, you know, for any reason I messed up or something, if I change one data value, it will recalculate these statistics here for me. So, remember, this is my average, okay? Don't forget that. All right, so I did the Miami Heat, but now I kind of want to do, I want to do the Thunder, okay? So I have 82, 82, 81. So I can just change these numbers. I don't even need to, like, do anything else. So 82... 82, 81, sorry it's so small, and 75 and 79. Okay, and you'll see it recalculated everything for me. Okay, so now the mean for this data set is 79.8. Okay, alright, so now I'm going to finish doing that. I just want to show you that real fast. Okay, okay, so you see that I've filled in all these charts here. So don't worry about filling all the charts in. Right now I just want you to focus on the video and listen to what I'm saying, okay? So if you want to, just fill in the mean down here and the average of the absolute deviations. Okay? Alright, fill those in. Okay, so which two teams have the same mean? Alright? I don't know why I just wrote 79.8. We see 79.4 there and 79.4 there. So the Spurs and the Heat. Okay? Alright, Spurs and Heat, whatever. Wrote it in the wrong place. Alright, which team has the largest mean absolute deviation? Okay, so we have 2.16 versus 2.24 versus 2.88. So clearly 2.88 is the biggest number. Right? And that's what this is finding. It's the average of the absolute deviations. Okay? So 2.88 is the biggest one. Okay? So that means that this data is most spread out. Most spread. Okay? And so the smallest one is the Heat, which is at 2.16. Okay? So they're the least spread out. Okay? So, no big deal. They have the smallest mean average deviation because it's the least spread out. Okay? Now, one thing you can do is in your calculator, if you wanted to make a new list, you could say, all right, here we go. 3.6, 3.6, that's 36. All right, 0.4, 1.4, and 5.4, right? So these are now my calculated absolute deviations. Say I want just the mean of that. Then I can again do menu, statistics, and stat calculations. Alright? You push one variable statistics, and it will give you the average of this column, whatever you type in, as long as it's in that column and you do one variable statistics for that column. Right? And now, note this box, one of your boxes in the column you want to find the statistics for has to be highlighted. Otherwise your calculator doesn't know what column you're talking about. Okay, so that's pretty important before you do it. Okay, so anyway, there's that 2.88 right there. Okay, same thing. Okay, moving on. Alright, so here's the formula that you're given on your formula sheet. So if you want to flip to your formula sheet, or you can look at, actually leave it on this page because it looks the same in both places. Okay, so this little dude here, alright, that means the sum, okay? Add those together, alright? So let's work from the inside out, okay? So xi means each element of the data set, subtract the mean from it, okay? So then take the absolute value of whatever you just found when you subtracted it, alright? And you do that for each element of the data set, okay? The I, we see this cycling through each element of the data set, from 1 to all of your elements, okay? So you do that for each element, and then you add them all up, and then you divide by n, the number of things in the data set, okay? So xi is each element, this is on your formula sheet, n is the number of elements, mu is the mean, okay? And on your calculator it's x bar. And sigma means add, find the sum. Okay, so the MAD, the mean absolute deviation, tells you the spread of the data set. Okay. Alright, so there's some practice problems on here. First, I just want to take 1 second to look at this here, okay? Which one of these is more spread out? This one, okay? We should have said this one. You should have this on your paper too, okay? So we see that this is really concentrated. The mean on this one is at 45, right? So this data is really concentrated about the mean. All the data is pretty close into that mean, but here the mean is also 45. But that data is spread. You know, you have stuff all the way in the 1 through 10, and then even the 61 to 70, okay? So this is more spread out. So which one would you expect to have a higher mean absolute deviation? Well, it's going to be data set 2. Alright, this is going to have a higher MAD because it's more spread out. So when the MAD's higher, it's more spread out. Okay, that's the number one thing you got to take away. When it's higher, it's more spread out. Okay, alright, so there's lots of practice problems on there. Tonight I want you to go and practice those. Okay, and we're going to ignore that for now. Alright, so I want you to practice tonight. We're going to go over standard deviation and variance here in a second, okay? But I want you to practice the mean absolute deviation and standard deviation tonight for homework so you can ask questions tomorrow when I come to school, okay? Alright, so now go ahead and get out the piece of paper, or flip to the page that starts off with this, variance and standard deviation, okay? So, the sum of the deviations from the mean is equal to 0, okay? So we looked at one way to address that by taking the absolute value of the deviations. That got rid of my negatives. And that found us the MAD, the mean absolute deviation. The second way to address this would be to square the deviations, okay? We've seen that when we square things, no matter what the sign is originally, it always comes out positive, okay? So instead of taking the only difference between this formula here for variance, which is what we're looking at now, the only difference between the variance and the mean absolute deviation is that this chunk, the deviation, is squared instead of taking the absolute value of it, okay? So look at this breakdown, okay? It means to square the difference of each element and the mean, okay? So you subtract the mean from the data element, and then you add those up. That's what this little sign thing means. The little e means add those up and then divide by the number of elements in your data set, okay? So to find the variance, start by finding the mean of the data set, okay? Then find the deviation of each element from the data set and the mean, okay? Then square each difference, and then find the average. Why did I put an extra A in there? Average of the squares, okay? Alright, now note, squaring those differences is going to weight big distances, right? So if I have data points, here's my mean. If I have a data point here and then a data point all the way down here, right? This distance squared is going to be significantly larger than this distance squared. Okay, so it's going to weight that bigger distance more, okay? Because you're squaring it. So it weights bigger deviations. I guess bigger differences is the answer. Bigger differences more heavily than smaller differences, okay? Alright, it also squares the units of your data set. Okay? And the symbol for variance, and this is very, very, very important, ready? The symbol for variance is this little squiggly guy. He's like an O with a hat on, okay? And he's squared. And you see that on your formula sheet. We have the O with the hat on, and he's squared, okay? Oops, that's not what I wanted. This is what I wanted, okay? Alright, so on the graphing calculator, if you scroll down in your data set, so if we look at our old data set, I can scroll down through this thing, and it'll have this thing called SSX at the bottom. If I highlight it, it shows what the formula is at the bottom, and right there, that's the numerator, right? This is the variance equation. That's the numerator of the variance equation. So all I have to do to find variance at this point is take this number, 15.782, and divide it by the number of things that was in my data set, which was 5 originally. Okay? But now, well, I guess we'll find the variance of one data set, okay? So go ahead and make a new document, okay? Because we're about to enter some new data, and add lists and spreadsheet, okay? So it's just, for good habits, let's call this X, even though we don't really need to. It's a good habit to do that, okay? So we're going to find the variance of each of these sets to see which one is more spread out, okay? So let me see if I can get this squished so I can see the sets. Alright, yeah, so we have 79, 82, 77, 85, 72, and 82, okay? Now we want to find our statistics here. So we do menu, statistics, stat calculations, and one variable statistics. Okay, I only want one list, and note, you see my box, it's right there. It's in my column that I want to find the statistics of, so I push OK, and there we go, there's my statistics. So to find the variance, I'm going to look for that SSX, okay, 105.5. And I'm going to divide that by the number of elements, which is 1, 2, 3, 4, 5, 6. Okay? And so that variance is going to be, hello, okay, 105.5 divided by 6. 105.5 divided by 6. 17.5833. Okay, so if we do it again, okay, so let's add a new page. Alright, we'll call this one Y. Alright, we'll do it again for the Michigan team. So 71, 78, 87, 79, 61, and 76. Okay, I push menu, statistics, stat calculations, one variable statistics, push OK, boom, statistics, love it. Okay, so SSX is 381.333 divided by 6 things in my data set. So let's calculate that. 381.333 divided by 6, and that gives me 63.56. Okay. All right, and what's causing this thing to be so much bigger than the other one is this 61, okay? If we look at our calculator, right, the mean of this data set is 75.333, but 61 is super far away, and so that's being weighted really, really heavily. So is 87, right? So we just have some big outliers on here that are causing it to weight the variance pretty significantly. All right, so which one is more spread out? Michigan is much more spread out because the variance is much higher than it is for Louisville. Okay, so if we want to get the units back down to the original units of our data set, so in this case I believe it was inches, right now we have inches squared, right? So that doesn't make a lot of sense. So what we need to do is we need to take the square root of the variance, which is called standard deviation. Okay? Alright, so it's the positive square root of the variance of the data set, and a greater value for the standard deviation, the more spread out the data are about the mean. Okay, so the same relationship as variance has to the mean and as mean absolute deviation has to the mean. Okay? So the lesser the value, the standard deviation, the closer the data are spread out or dispersed. Okay, so dispersed can go here too. About the mean. Okay, so if you look at your formula sheet, the symbol for variance is dude with a hat on squared, right? And the symbol for standard deviation is just dude with a hat on, right? So how do I get from dude with a hat on squared to dude with just a hat on? Well, I took the square root of him, right? So then the variance is just, or the standard deviation is just this square root. Okay? And this thing is the dude with a hat on squared. Okay, so it's the square root of the dude with the hat on squared, all right, which is this little thing. Well, great news, everybody. That shows up in your calculator, right there. That's your standard deviation. Isn't that amazing? You don't even have to think about that. There's your standard deviation right there, okay? So it tells us my standard deviation is 7.97217 for that data set we looked at above. All right? And so if I want the variance, all I have to do is square that number, okay? To go from standard deviation to the variance, I square it. To go from variation to standard deviation, I take the square root, okay? So then my variance would just be 7.97 squared, which is 63.5. Go figure. Weird. We just calculated that and it worked anyway, okay? So as long as you can find this little dude in here, no matter how confused you are, if you can find him, the guy with the hat, wearing a hat, chilling, you know, just hanging out, playing with statistics, right there, you can find variance and standard deviation, no problem, okay? Easy peasy lemon squeezy, all right? So, to find that standard deviation for Louisville, 17.58333, hello, and then 63.5, that would give us the standard deviation. Okay? Alright, so I think your class is about to end. So this is on YouTube, alright? This is where you're watching it right now. And so what I want you to do is go home tonight. I want you to practice this. You have tons of practice available. Don't go really beyond the original standard deviation sheet. If you get a new title, you're good. You don't need to keep going, okay? Just try the mean absolute deviation, try your standard deviation and your variance, and then bring questions to class, alright? But if we can master this on our own, we're good to go, okay? The key is that you understand that these are the spread, and if you can get that and you know how to work the calculator, you're pretty much good on the statistics, okay? So I'll see you guys tomorrow. I hope you have a great day, and if you're confused, you can go home and watch this video again, all right? All right.